welcome to grade 10 academic math, and today's lesson is the sine law. So let's just review a couple of things about triangles and labeling triangles that are super important. The first thing is that sides are always labelled with small letters. Okay, sides labelled with small letters. S for small. All right, whereas angles are labelled with capital letters. So just think about the letter A, and it kind of looks like an angle, right? This kind of looks like an angle, right? An angle A, all right? So just remember that. So let's completely label these triangles, and there's a couple of more rules as we go. So labelling the sides of a triangle, typically we look at the labels of the angles of the triangle, or the vertices. I should really call these vertices as well. Vertices, which is plural of vertex. Look at the vertices of this triangle, and the side length is labelled with a small letter of the angle opposite to it. So, for example, this is Q, and so the side opposite to it over here will be labelled little q, like so. This is angle R, so the side opposite is labelled little r, and so on, and little p. When we have the sides labelled but not the angles, we can go in reverse. So the angle opposite the given side has its capital letter equivalent. So that will be X, this one will be Z, and the other one is Y. So now putting it all together now, so we have angle D, so therefore this side opposite is going to be called letter D, small d. We have a small a indicating the length of this side, and so the angle opposite to it is going to have a capital A, and likewise the missing angle is going to have a label of capital C. So the primary trig ratios, as we've discovered in the previous lesson, sine, cos and tan, can only ever be used when we have a 90-degree right angle. So when we have a triangle that does not have a 90-degree angle, and such as this one given, then we have to use something called the sine law. Now, even though you might look at this and say, oh, Mrs. Hooker, this is a 90-degree angle. No, it is not. Unless it has that little square in there, it is not 90 degrees. It may be very close to it. It might be 89.5 degrees. I don't know. Don't get a protractor out. Whatever you do, do not get a protractor out. That's not what we do in grade 10. We just go by what is labelled. So this one, we can't assume a 90 degrees, therefore we have to use something called the sine law. Let's first of all label this triangle. So we have a side length of little a over here, side length little b, and side length little c over there. And the sine law basically says this. We have two versions of it. So basically it's looking at, we'll start off with angle A. So angle A is always attached to sine, so it would be sine of A divided by A equals sine of B divided by B. And there is a proof to all this, but for now, just write this down. Now, you might think, hey, this is strange, I've got two equal signs on the same line, and yes, it is. This is just the actual law, and when you're actually using it, you're only going to use two parts of it ever, 2 parts out of 3. So you'll either use this bit, or you'll use this bit, or maybe you'll scrub this middle bit out altogether and just use the left side and the right side. Okay, so you either use A, B, B and C, or A and C, or whatever letters your triangle happens to have. Now, there are two forms of the sine law, and from down here, there are two forms. I'm just writing them up here for now. So there's this version, and then there's this version starting with little a on top, and the signs on the bottom. So the sides on top and the signs on the bottom. Now, it doesn't really matter which one you use. I know that you'll be well adept at manipulating any equation to isolate for a missing variable, but often you'll find that it's easier for finding missing angles to use this one, and it's easier to use this one for missing side lengths. All right. But you can you can use either. It really doesn't matter at the end of the day. They're both the same. Okay, so sine law can be used when you know two angles and one side, or when you know two sides and one angle. So when you know two angles on one side, it can be used to find the other side. So to find a side. Or when you know two sides and one angle and you want to find an angle. Okay, now there's some rules with it. All right, so let's take a look. So I want to maybe draw a triangle here. It's not a right triangle, okay? And let's suppose we are given this first scenario. Let me highlight this in yellow, and this will be our yellow example right here. Okay, let me just do that a bit nicer. I'll just highlight that in yellow as my yellow example. Okay, when you know two angles on one side, so let's just check these off. When you have two angles and one side, let's suppose you have, which side? Well, really, it's got to be a side opposite and not one of the given angles. But it really doesn't matter, because if you have two angles, then you can always figure out this one anyway. So it really doesn't matter which side. But what we do need to be able to do is identify two given ones there, and then maybe the one that we're missing is here. And so we can use the three given values, those three blue check marks, and then we can have the missing one. I call this drawing baby carrots around, right? If you can draw two baby carrots around that have three given values and one missing value, then you can use sine law. The other option, which is when you know two sides and one angle, let's draw a triangle and demonstrate that one too. So when you know two sides and one angle, now this is the key. The angle has to be either this one or this one, okay? It cannot be this one, all right? Because if you're given that one, let me do that one in red. If you're given that one, then you can't use sine law. And the reason why is because you need to be able to draw a baby carrot around that, okay? And we want to find a missing angle. So what we can do is we can find out this missing angle, which will be this one right here now. Change that for a question mark. And you'll be able to use sine law. Okay? But you'll notice that you would not be able to draw a baby carrot around this one, because not only is the angle missing, which we don't know, but also the side is missing as well, and we can't have two unknowns. Okay, so that would be the situation for this. Now I know you might be thinking, okay, this is a bit complicated. Yep, it's not really. Let's jump into some examples and then you'll see how easy it actually is. So given this triangle DEF with two angles on one side, find the missing values. Okay, so we need to find E and F. So let's highlight what we have so far. So we have this length. We also have this angle, and we also have this angle. And because we have two angles in the triangle, we could find the third one if we need to. But let's see what we can highlight first with drawing around it. So we have an angle and its opposite side right there. And we have this angle, and do we need its opposite side? Yes, we do. So let's calculate E first. So this is how I like to start off. Yes, we have the sine law. So basically this is how it goes. And the sine law that we quoted up here used A, B, and C. So I'm going to show you how to adapt that to this triangle. For this triangle, start off with our missing value. So our missing one is E. So let's start off our sine law with that, and I'm just going to define the sine law for this triangle first. Missing side length of E. They go on their own. And then we'll divide that by sine of its opposite angle, E. That's easy enough. And that's equal to, now we're going to choose which side we use next. And we'll choose that by looking at the one that we have the values for, which is angle D and side D. Let me label that side length D. So that will equal, back to our sine law now, E over sine E will equal D over sine of big D. And now we can substitute for the values we know. So my E is still unknown, but I do know sine E is going to be just sine of angle E, which is 50 degrees. Set that to equal. Side length D is 54. We don't put units in right now, only at the end. And sine D, which is sine 34 degrees. Okay, now the next step is super simple. We need to get E on its own. It's been divided by sine 50, so we multiply by sine 50 both sides. When we do that to the left, it disappears, and basically we just, it's called cross multiply. So therefore we end up with E on its own, and that will equal, we'll keep that 54 at the front so it doesn't get mixed up with the angle, and then write the sine 50, which is a term all on its own, and then divide that by sine 34. Now it's time to get your calculator out and put that in. So please use brackets if you wish, or you can just type it in. Should be able to type it in 54 sine 50 divided by sine 34, and your calculator should know. Now we get a decimal for an answer, so let's just focus. What is it we're finding here? We're finding a side length. So because we're finding a side length, we need to round to one decimal place. That's the general rule, 1 or 2 decimal places. In this case, I'm going to go with 2 because I get 73.98. Alright, actually let's round that to 74. So 74, and we're in meters, so 74 meters. Okay, let's put the therefore sign in there. Okay, so we found our E. Now we need to find side F. Okay, so back to where we were before. Now we have to find side F. Now to find side F, think about this. We need to know angle F, and we actually can find angle F because we know that angle F is simply 180 degrees, which is the interior angles of a triangle. Let's subtract the other two ones that we have, minus 34 minus 50. So 180 minus 34 minus 50 will give us 96 degrees. Okay, so I know my F is 96 degrees. Let's put equals 96 degrees. And I can set up my sine law part 2. And let's do this. So I have my missing value is F, little f for the side length, divided by sine F will equal, and let's just go with the same one that we had before, the D over sine D. So those were the values given to us. Better to use that than to use the ones we just calculated, just in case you made an error. So therefore we have little f divided by sine of our new angle F, which was 96 degrees, is equal to 54 over sine 34. And cross multiply again, cross multiply that denominator up there to give us F equals 54 sine 96 divided by sine 34. Put that in your calculator all at one go. Please don't chop this up into bits, just do it all at one go. It's so much easier and more efficient. I don't need to see the interim calculations. So therefore F is approximately equal to 96, and let's not forget the units now, which is in meters, and that's it. So we have our missing values. We have our missing value of E, which is 74 meters, our missing value of F, which is 96 meters, and our missing angle F, let me just label that here, which was 96 degrees. And that's it, we've solved that triangle. Okay, let me just do that again one more time, highlight it properly this time. There we go. Okay. All right. Now, what if you're given something that needs a diagram? Maybe either you're good at drawing diagrams or you're not. So I'm going to show you how to tackle this both ways, if you want to draw a diagram or without a diagram. So let's go first of all without a diagram, because maybe drawing diagrams isn't your thing. I don't know. I like to draw diagrams, but let's do that one next. And you choose which you prefer. Okay? So let's have a look. We've got triangle DST. If you don't like drawing a diagram, let's draw out. We've got angle D, angle S, angle T. And then we'll therefore have side D, side S and side T. Let's fill in what we've got. Triangle DST, angle D is 47 degrees. Let's put that in. Side D is 78 centimetres. Side S is 106 centimetres. Find the measure of angle S. So our question mark is right there. So this is fairly easy without a diagram. You can therefore basically highlight the two values that you have opposite each other and the two values where you've got one value that you know and the one that's unknown. And let's set up our sine law. We're starting out with a missing angle this time, and angles are attached to the sine. So sine of S divided by little s will equal sine of D divided by little d. We're using D because we don't have any values given for T. Now let's substitute what we have. Sine S, we don't know S, so leave it like that. Little s is 106. Sine D is sine 47. And little d is 78. Now we've got, this is a bit of two steps now. We've got to cross multiply the 106. So we end up with sine S on its own, which will equal now the 106 that we cross multiplied, and I'm putting it in front of the sine 47, oops, just to make sure it doesn't get muddled up with that angle there, divided by 78. And now we need to get S on its own. Now, do you recall how we extract S from sine? What's the opposite of sine is inverse sine. So when we do inverse sine of sine, it just gives us the angle. And then we have to do inverse sine of the other side. Now, this is where you definitely need to use your brackets on your calculator, folks. So let's go do that. So inverse sine, press your shift button or your second function button and sine, then use brackets. And then do 106 sine 47 divided by 78. Close your brackets up, press equals, and it should give you an angle value of 83.66. We'll round that to the nearest whole degree, like so. And that's it. So that's how to do it with without a diagram. Now with a diagram, you have to be fairly adept at drawing triangles, so let's give it a go. Angle D I know is 47 degrees. So let's go with something like that. Maybe that, not that. See, maybe I'm not so good. Maybe we'll do angle D like that. Okay, I'm thinking that's my D, which is 47 degrees. Side D is going to be opposite, 78. Side S, what am I going to do? The 106, maybe I'll call this 106. So this will be a little s. And this is my big S, and that's my big T and my little t. Okay, and then you can draw your baby carrots around your two known values and the ones that you're trying to find, which is this one. Okay, and then we set it up exactly the same. Then you go sine S over little s equals sine D over little d, and substitute your values in, and then it's just the same as what we had before. Okay? So if you feel happier drawing a diagram, and that diagram kind of gives you a sense as to whether your answer is right. So I'm looking at my answer of 84 degrees and inspect this one. It kind of looks like 84 degrees. Maybe that's just by fluke. I don't know. You know, diagrams aren't always accurate and don't have to be accurate for the purposes of this lesson. Without a diagram is definitely fairly easy to see, I hope. So let's have a look at one example 4. Pardon me. The perimeter of the Bermuda Triangle. Use the information given on the diagram to determine the perimeter of the Bermuda Triangle to the nearest 100 kilometers. Okay, so a perimeter, remember, is going round the outside of it like so, right, and measuring all those values. So we therefore need to find out the missing values of side S over here and side M over here. Okay? And all we have are two angles and a side. Okay. So first thing to note is that let's try and find out side S. Okay? So side S, we do have an angle opposite. That's good. Now we need to draw another baby caret around the two values that we do have. Now we have 1800, but we don't have angle B. So that's the first thing we're going to have to calculate. We know that's easy because we already have two given values of M and S. So angle B is simply equal to 180 minus angle M and angle S. In other words, 180 subtract 50, subtract 74. And that gives me, I'm being lazy using a calculator instead of my brain, 56 degrees. All right, so let's start by writing that in there. And now I have my values that I need. Okay, so side length S divided by sine of S is going to be side length B divided by sine of B. And this is my side length B right here, 1800. So side length S divided by sine of 74 is going to be equal to 1800 divided by sine of 56. Cross multiply up there. Now remember, we don't really want that sine 74 to be in front of the 1800. Right? We are going to put it at the back of the 1800 just so that that 1800 doesn't get muddled up with the angle when we put it in our calculator. Okay, so we have letter S is equal to 1800 times sine 74 divided by sine of 56 degrees. Okay, let's put that in. 1800 sine 74 divided by sine 56. And I get 2087. I'm going to round it to a whole because we're meant to be rounding the entire perimeter to the nearest 100 kilometers. So I'm quite happy with that. Okay. Now we need to do the same for M. So I'm going to go over here with M. I know that M over sine M is equal to, we'll do B over sine B again. Substituting our known values, M over sine 50 this time is equal to 1800 divided by sine 56. Cross multiplying, we get M is 1800 times sine of 50 divided by sine of 56. And just put that in your calculator. Sine 50 divided by sine 56. And that gives you approximately 1663 kilometers. Okay. All right, we are almost there. We now have side length S and we have side length M. So to find the perimeter, therefore, so the perimeter of the triangle is simply adding those together. So we have the original 1800 kilometers plus the 2087 plus the 1663 that we had. So let's add those together. Note that I didn't put units in, and I don't need to put units in until the very end. 1800 plus 2087 plus 1663, and that's 5,550 kilometers, and that's it. We are done, except to the nearest 100 kilometers. Okay, so to the nearest 100 kilometers, maybe I should have gone for decimal places. Let's see. I'm going to go back in my history. This was actually 1663.23, and this one was actually 2087.08. So if I added those little bits on the end, we'd actually be at 5,550 point, what would that be, 331. So to the nearest 100 kilometers, therefore, the perimeter is about 5,600 kilometers. Okay, to the nearest 100. It just so happened that this, whoops, where did I go there? Oh wait, to the wrong lesson. There we go. It just so happened that this valley right here is right slap in the middle between 5,500, 5,600, which is why I needed to go back. Oh my goodness me, sorry about that. Why I needed to go back and make sure I included those decimals. Okay. Example 5, and then, oh gosh, this is a long lesson. Example 5, a cottage under construction is to be 12.6 metres wide. The two sides of the roof are to be supported by rafters that meet at a 50-degree angle. How long should the rafters be if they are the same size? Okay, let's do a diagram. This is definitely a diagram. It's got to be 12.6 metres wide. Let's draw a 12.6 metre wide line, which goes from there to there. The two sides of the roof are to be supported by rafters that meet at a 50-degree angle. Okay, so we have rafters that meet at 50 degrees, like so. And we're assuming the rafters are the same size. How long should the rafters be if they are the same size? Okay, so I think likely we are going to be finishing our rafters right at the edge of the house, like so. Okay. So how long are these rafters going to be? That would be this value here. Let's call it A and A. They're both A's. All right. This is an isosceles triangle because those rafters are the same length. So I know that I can calculate this angle here because it will be the same as this angle. I have one angle of 50 degrees and I know that my missing angles, which we call this one A, so my missing angle is going to be simply 180 minus the 50, and then we'll divide all that by 2 to get that missing angle A. So that will be 130 divided by 2, in other words, 65 degrees. Okay, let's write that in. 65, 65, do a quick check. 65, 65 and 50 is indeed 180. Good. And now we need to find that length. So we can draw a caret around the two values that we have, an angle and an opposite side. And let's draw the next caret there. We need A. So A over sine A, always start by stating your sine law, equals, let's call this B and B. So B over sine B. Substitute the values we know. A over sine 65 is going to be little b, 12.6. If there's ever anywhere where students make an error, it's in using the wrong values. Put them in the wrong spots. Putting in a length for an angle and an angle for a length in error. Cross multiply. So you end up with A equals 12.6 times the sine of 65 degrees. And then divide that by, oops, sorry, I don't have my glove on, so it's just a bit jumpy sometimes. Sine of 50 degrees. Put that in and let's see where we're at. 12.6 times sine 65 divided by sine of 50. And that gives me approximately 14.91 meters in length. Okay, so the rafters should be, should be at least 14.91 meters long. Now typically, I know in real life rafters often come down because you have that little bit of an overhang, but yeah, for the purposes of this question, that's all I need. Okay. Sometimes you'll have to use both sine law and primary trig ratios. Now remember, please use primary trig ratios if the triangle is a right triangle. Sorry for my squeaky chair there. But if it's not a right triangle, you have to use sine law. So Jansma and Hooker are determining the height of a cliff they plan to climb. They are 18 meters apart on the same side of the cliff. Okay. So we're going to climb the cliff, so let's do the cliff here. Cliffs are usually vertical, right? So there's your cliff. And here's your ground level down here, like so. So let's see. Jansma views the top of the cliff. Let's just put the two of us here. I don't know who's who yet. Let's see. Jansma views the view of the top of the cliff at an angle of elevation of 23 and Hooker views it as a 29 degree. So let's put some sight lines in there. This one will be a bigger angle than this one. All right, we've got two angles going on. We've got this one, and we also have this one. The bigger of the two angles will be the red one. So the bigger of the two angles will be me. So I'll be there, H, we'll call it H, and that's 29 degrees. And Jansma will be over here, and she's seeing it at 23 degree. How high is the cliff? Okay, so we want to know this, H. We'll call this H, this length from the very top of the cliff to the very bottom of the cliff. I do know that that's 90 degrees, so maybe we can use that. Okay, seems reasonable. What else do we know? Oh, that we are 18 meters apart. Good, I'm glad we have that information there, 18 meters apart. So that's from this to this, right here, okay? So I think I'm going to need to use that because I'll likely need to find something. All right, if I need to find this H, let's see. I can either use this right triangle, which I really only have the angle for, nothing more. Or maybe I can use this triangle where, again, I only have this angle and no more. But I do have this, and I do have this triangle here, where I have a given angle, I have a given side. I can find this angle, this one here, and I can also find this angle if I want to. And so I'll be able to find out this length right here, or this one. Entirely up to you. There's so many ways of solving this question. I'm going to go with finding this length here. That's what I'm going to focus on, because that is a length opposite a given angle that I have. Maybe I won't find this length. No, maybe I'll find this one. I'm changing my mind. Really doesn't matter. I'm just trying to make it easier for you. Let's start off by filling in what we can. What can we fill in is this angle. I know that angles on a straight line add to 180. So 180 minus 29 gives me 151. So I know that that's that angle there. Now getting my calculator out, now I have the two angles. And those two angles total 174. So therefore it means this angle here, this little itty bitty angle, is 6 degrees. Okay? So you can start by filling in information like that. And now we can really use that to our advantage. And let's find this length here. I'm going to call this length L. I'll highlight it too so you know which one I'm talking about. This length. We're going to find that. So let's put a circle, or sorry, a caret around the two values that we do have there, and the value that we also have, but the length that we need right there. And let's write out our sine law. Straight off, our missing side length L divided by sine of the angle opposite, which is 23. So you'll see now I've progressed from using letters, which is equal to my given side length that I know, which is 18 divided by sine of its opposite angle, which is 6 degrees. Cross multiply, remembering to put the sign at the end. So it'd be L equals 18 times sine of 23 divided by sine 6. And let's see what that gives us. 18 sine 23 divided by sine 6. Hopefully whilst I talk you through these, you are actually trying this on your calculator, making sure and confirming that you get the same that we do. I'm going to leave this to 3 decimal places just for accuracy. Now we're dealing in meters. So 67.25 meters is L. And now that I have that, let's extract this triangle now. So what do I mean by that? This triangle here that I'm drawing over in green is a triangle we're now going to use to find my missing value of H. Whoops, I didn't mean to do that. Goodness, there. All right, well, I've kind of messed that up a little bit, haven't I? Let me just draw some lines back in. I forgot about me having those lines in there. There we go. Okay, let's erase that and label it what we have. H, we have a right angle my L, which is now 67.285. I'm just duplicating this just to make it a little less cluttered, 29 degrees, and we need to find that H. So now we can use a primary trig ratio in that I have the hypotenuse and I need the opposite, and the adjacent is not going to be used at all. So I'm using the O and the H, and remember so katoa, so, oops, undo, ka, toa. All right, and so therefore I need to use opposite and hypotenuse, so it would be sine. So in this case it will be sine of my angle 29 is equal to the opposite, which is H, over, that's little h that is, over my hypotenuse length, which is 67.285. Now I actually left that 67.285 unrounded in my calculator in front of me. I didn't press clear because I now know that I'm going to cross multiply this. So my h is simply going to be 67.285 times sine of 29. So leaving it in my calculator, I can just hit multiply sine 29. And that will give me a more accurate answer of 32.6. I'm going to round that now, though, to 32.6 meters. So we can say, therefore, the cliff is about, because I'm rounding, 32.6 meters high. Okay, so in summary, to use sine law, you'll need a matching pair of sides and angles. All right, so sine law again. All right, this is not ratios, this is sine law. So a matching pair of sides and angles, or an angle and a side, and an angle and a side. Okay, so you need to be able to draw hoops around those two. All right, in order to solve it. If you are looking for, okay, this is only suggested or recommended, but you can actually use either version. Recommended, if you are looking for a side length, then use this form. A over sine A equals B over sine B, which equals C over sine C. However, if you're looking for an angle, then use this form. And the only reason I say that is because there's just one step in the cross multiplication. If you happen to use the other form by mistake, well, it's not really a mistake though, if you just happen to use the other form, it just means you've got a bit more manipulation to take place. I guarantee some of you are going to do that and maybe end up in a pickle, or maybe you'll figure it out. If you do end up doing that, come show me and I'll show you quickly how to get out of that fix without having to redo the question. Okay, that is it. You have homework to do, and lots of it, I think. So good luck with that, and I'll see you next lesson. Bye.